I want you to imagine something just for a second. What if hell wasn't some fiery religious destination waiting for you in the afterlife?
Right, not the traditional pitchforks and brimstone kind of thing.
Exactly. What if, instead, hell was this quantifiable, mathematically precise state of systemic friction, like a state that you actually experience every single day?
Oh, absolutely. You feel it all the time.
Yeah, you feel it sitting at your desk when your entire organization just freezes up, or, you see it when a server architecture cascades into total failure.
Or even inside your own body.
Yes, you can literally feel it manifesting right inside your own nervous system
Right.
as this acute physical stress.
And, looking at it this way completely shifts how we view suffering. We move it entirely out of the realm of, like, theology or moral failing and directly into the realm of structural architecture.
Which is exactly what we're getting into today. Welcome to the Deep Dive, where our mission is to explore this really fascinating theoretical framework from the source text, The Cybernetics of Hell.
Yeah, the full title is Thermodynamic and Industrial Systems Mapping, which sounds intense, but it's brilliant.
It really is. I mean, my core takeaway from diving into this is that we're essentially stripping away the literal sulfur and fire and looking at how classical physics, go-native software engineering, and Toyota's lean manufacturing all map the exact same structural divide.
The divide between heaven, which is unburdened creation, and hell, which is obstructed, redundant effort. Because, knowledge is always most valuable when we connect the dots between seemingly totally unrelated fields.
Right, because when you realize that a burned-out nervous system and an overheated microchip are suffering from the exact same mathematical geometry,
Yeah.
you can stop just treating the symptoms.
Exactly. You start actually altering the structure itself.
Okay, let's unpack this, because this whole blueprint actually starts with something most people probably haven't thought about since high school chemistry.
The ideal gas law.
Yes, Boyle's law and the ideal gas law.
Right, so we're talking about PV equals nRTI. Pressure times volume equals the number of moles times the gas constant times temperature.
Which on its own is just physics. But the text does something really clever with it.
It does. What this framework does is perform what they call a Bateson move. It basically extracts the relational logic of those physical variables and translates them into a scale-free cybernetic model.
And they use this 5D primitive stack, right?
Yeah, they call it the abstract system graph, or the ASG.
The isomorphic translation here is just really elegant to me. So let's walk through it. In classical physics, you have volume, V.
Right.
And in the abstract system graph, volume translates to the boundary barrier.
B. Yes, B is the operational perimeter of a system.
So like the homeostatic shield enclosing the core.
Exactly. And that could be the literal cell wall of a biological organism or, the operational scope of a project team at your job.
Okay, got it. Then next is pressure, P, which translates to external entropy, X.
Right, so think of the kinetic force of gas molecules just continuously striking the walls of a container.
Just constantly bouncing against the sides.
Exactly. In our systems map, this is external chaos. It's unvetted demand or sheer kinetic force just pushing against the system's boundary.
Okay, and then we have the number of moles, N, which in physics is the actual mass of the gas.
Right, and that maps to the resource reservoir, R. This is the finite, quantized energy or attention that actually sustains the internal loop of the system.
Like your actual budget or your team's literal brain power.
Yes, exactly. And finally, you have temperature, T, which is the average kinetic energy of those molecules.
And in the cybernetic model, temperature becomes what they call dissipation as drag.
Which is such a great term. It's the thermal decay, that structural friction generated when a system is forced into repetitive, redundant cycles under heavy load.
Okay, let's put this into motion so people can really picture it. A stable system, like a homeostatic state, has a wide, resilient boundary barrier.
Right, high volume.
Exactly. Because you have high volume, the external entropy pushing against the perimeter is easily distributed. It's not overwhelming.
The internal resource reservoir can move freely without bottlenecking. Collisions are really rare in that state.
So the internal temperature, or the dissipation as drag, just remains near zero. The system communicates and operates without any friction.
And that is the baseline for functional creation. That's a healthy system. But Boyle's law dictates that pressure and volume are inversely proportional.
Right. So as one goes down, the other goes up.
Exactly. So as the boundary compresses, which the mathematics describe as B approaching zero, and external entropy spikes, the system is forced into this highly compressed defensive posture.
It's like you're trapping the exact same amount of energy, the same number of particles, inside a shrinking box.
That's a perfect analogy. You are forcing the identical mass of your resource reservoir into a suffocatingly narrow operational space. The particles are just totally trapped.
And their collision frequency goes totally exponential. They're just slamming into each other.
Right. What's fascinating here is that this exact state is mathematically defined as local hell.
Local hell.
Yeah. The system has to burn its resource reservoir at double or triple the normal rate, just to maintain its structural integrity against all that outside pressure.
And the real tragedy here, based on the text, is that none of this burned energy translates into useful progressive work, does it?
No, not at all. It is entirely lost as dissipated structural heat.
Which you see in the real world all the time. Like you see this as somatic tension in a human jaw.
Oh yeah, teeth grinding.
Right. Or you see it as actual processor heat in a throttled CPU.
Yeah.
Or even just pure panic in a compressed corporate division where everyone is freaking out but nothing is getting done.
The energy is being fiercely expended, but nothing is actually being transformed or created.
I do have to push back here for a second, though. I mean, if hell is friction and dissipated drag, and heaven is zero friction, doesn't a completely frictionless state just mean nothing is happening at all?
Well, it's a good question, but
Because, we always hear that we need resistance to build muscle, we need pressure to form diamonds. So why is friction inherently categorized as this hellish state?
so we have to distinguish between progressive load and structural drag. They are very different things.
Okay, break that down for me.
Progressive load, like lifting a weight or solving a really novel problem, is directed energy transferring into structural adaptation. It's actual transformation.
Okay, so the energy is going somewhere useful.
Exactly. Structural drag, on the other hand, is energy spent merely trying to access the opportunity to do the work. It is totally redundant, non-directional cycling.
Oh, I see.
Hell isn't the presence of hard work. Hell is the state where your energy is consumed by the architecture itself before the work can even begin.
Oh, wow, that makes the distinction incredibly sharp. So you're just fighting the system, not doing a task.
Precisely.
So what happens when that structural drag hits a mathematical limit? Because, if the external entropy just keeps rising and the boundary is completely locked, the system can't just infinitely generate heat, right?
Right. It hits what the framework calls the terminal threshold.
The breaking point.
Yeah. If the internal kinetic chaos reaches a critical limit, the core processing unit, which is labeled N1 in the framework, is at risk of irreversible structural damage. It's literally going to melt.
So what does this system do to save itself?
To prevent the destruction of N1, the boundary architecture executes an automated state transition. This is represented by the delta symbol in the math.
So it deliberately breaks a peripheral system just to save the core.
Exactly. Think of an electrical grid. This is a circuit breaker tripping. The fuse blows so the whole house doesn't burn down.
And what about in a human?
In the human nervous system, this mechanism is profoundly physiological. When cognitive and sensory pressure totally exceeds the threshold, the thalamic reticular nucleus forcibly shuts down sensory gating.
It initiates a dissociative split.
Yes. The system literally goes offline. It severs the connection to external entropy just to protect the core neural architecture from permanent damage.
Okay, here's where it gets really interesting. Because this thermodynamic map isn't just a thought experiment for neurobiology or physics.
No, it has very practical applications.
Right. According to the source, it is actively functioning as the architectural foundation for bare metal software engineering.
Yeah, this part is wild. There are compute engines written in Go native code that process this exact thermodynamic topology.
How does that even work in code?
Well, they utilize standard 5D activation vectors. So that's the N1, N2, B, R, X we talked about earlier. And they allocate the entire state matrix directly onto the stack memory of a Go routine.
By mapping the system mathematically rather than semantically.
Exactly. And by doing that, they completely bypass the Go heap entirely.
Which means absolutely zero garbage collection overhead. That is insane.
It's incredibly efficient. The engine can evaluate the entire state of a massive system with zero residual memory footprint.
But the brilliance of this architecture, from what I read, is really how it handles reality checking through this thing called the governor agent.
Right, the governor agent. So
Yeah.
typically, if you want software to determine if a narrative or a systemic claim makes logical sense, you'd route it through an LLM.
Like ChatGPT or something.
Yeah. You ask a non-deterministic probability-based model to guess if the scenario is true. But LLMs hallucinate, right?
Oh, all the time.
Because they don't understand physics. They only understand statistical word proximity.
But the governor agent doesn't care about word proximity at all.
Not even a little bit. It uses deterministic invariant checks derived directly from that thermodynamic ratio we were discussing.
But wait, how does it actually extract a pure mathematical ratio from raw human language or like a database input?
It parses the structural claims of the transaction. So say an input narrative claims that an entity experienced massive boundary compression and external entropy just speak to infinity.
Okay, so massive pressure, tiny box.
Right. The code plots those coordinates into the 5D primitive stack. It then calculates the necessary thermal output.
The heat that should mathematically exist.
Exactly. If the input then claims zero internal heat was generated, or that the resource reservoir remained totally untouched despite all that compression, the mathematical invariant fails.
Boom. Caught in a lie.
Exactly. The code flags a false reservoir injection and instantly kills the transaction.
It just terminates it.
Yeah.
It knows the narrative is a lie because the thermodynamic topology is literally impossible.
It enforces the sterile, unyielding laws of the physical universe over raw human language. And it does this in real time during a database transaction.
It is basically using the geometry of reality as a lie detector.
Which is such a powerful concept. And because this geometry is universal, we can pull it out of stack memory and apply it directly to human organization too.
Right. Which brings us to the next big shift in the deep dive. Because the mechanics of how value moves through a Go routine are apparently identical to how value moves through a literal factory floor.
We're talking about lean manufacturing now, production flow theory.
Specifically the Toyota Production System, or TPS. And what's cool is TPS doesn't use the vocabulary of, like, spiritual salvation, but it rigorously defines this exact structural divide we've been talking about.
Yeah, in industrial theory, heaven is defined as one-piece flow.
One-piece flow.
Right. It is just-in-time, value creation, and direct transformation. A healthy production architecture receives a legitimate demand and translates it into finished value with minimal delay.
Zero hidden inventory.
And no interpretive drag.
It is just unburdened creation, which means industrial hell must be obstructed rightful motion.
That's exactly it. It is a system that works endlessly but redundantly. It's a system that's completely unable to distinguish actual value creation from mere ritual.
And the framework actually maps this out through Taiichi Ohno's 7 classic wastes of lean manufacturing.
Yes, the 7 wastes.
And we really need to be careful with the word waste here, because we tend to think of waste as like literal garbage in a trash can.
Right, physical scrap.
But structurally, waste is effort that is entirely detached from rightful transformation.
Yeah. If we group these 7 wastes thematically, the isomorphic mapping to our thermodynamic model is really striking.
Let's go through them. Look at the waste of time and space, which are waiting in motion.
So, waiting is simply obstructed time where the resource reservoir is burning without any actual forward movement.
You're paying people to just stand around.
Exactly. And motion, or unnecessary transportation, is the curving of lines replacing a direct path. It's movement without progress.
Okay, then you have the wastes of potential, which are overproduction and inventory.
Overproduction is premature manifestation. It's forcing something into existence before a legitimate demand has actually called for it.
You're just making stuff to make stuff.
Right. And inventory is frozen potential. It's energy that has been expended and is now just trapped inside a physical object that cannot yet be utilized.
Just sitting on a warehouse shelf gathering dust.
Exactly. And finally, you have the wastes of distortion, overprocessing, defects, and rework.
Okay, break those down.
Overprocessing is ritualized excess, doing way more to a product than reality actually requires. Defects obviously represent failed incarnation.
It didn't work.
Right. And rework is the ultimate manifestation of hell.
Ah, the double push.
The double push. Rework forces the system to spend its finite energy repairing the consequence of its own architectural distortion before it can even resume a baseline state.
So you're paying twice for a single step forward.
Exactly. And in doing so, you're generating massive amounts of dissipation as drag.
This maps so flawlessly onto modern knowledge work. I mean, we walk into an office or we open up our digital workspaces like Slack or Teams, and we see frantic activity.
Notifications everywhere.
Right. Everyone is exhausted, so we just naturally assume productivity is high. But we are completely blind to the fact that most of this motion is purely compensatory.
We are just managing the system's internal fragmentation. We aren't creating anything.
And queuing theory mathematically proves this illusion, doesn't it?
It does. If we look at John D.C. Little's work and Kingman's heavy traffic approximations, we can actually see the structural geometry of time changing under load. Well, as a system's utilization approaches maximum capacity everyone is at 99% bandwidth. The introduction of even minor variability causes waiting time to expand disproportionately.
So the geometry of the system fundamentally warps.
Yes.
It isn't like a slow-moving traffic jam where everyone's just tapping their brakes. It's more like the phase transition of water freezing into ice.
That's a great way to picture it.
Because as the space compresses and the temperature drops, the water molecules don't just, slow down. They instantly lock into a rigid crystalline lattice. The whole system crystallizes.
Work begins to wait on work.
The pipeline solidifies entirely.
Exactly. You are feeding more energy into the system, burning more fuel, but you're producing less actual flow out of it.
The system ceases to create value. Its entire functional capacity is consumed by just maintaining the consequences of its own overload.
And when you analyze a frozen system like that, you almost always find it orbiting around a single constraint.
Right. The bottleneck.
The theory of constraints, which was developed by Eliyahu Goldratt and later expanded by Donald Reinertsen, identifies the bottleneck as the governing reality of any system.
Structurally, the text says the bottleneck functions as a false god within the architecture.
It really does. You might possess 1,000 highly efficient nodes, but your total throughput is utterly subordinate to that narrowest passage.
The entire system is defined not by what it can do, but by what it cannot pass through cleanly.
And this has a very direct neurological equivalent, too.
Oh, right, the brain stuff. When you look at the human brain under extreme stress, it falls into what they call the default mode network trap, or the DMN trap.
Right. When the nervous system is overloaded and just cannot process forward action, the brain begins to orbit an unresolved constraint.
We call it rumination.
Right, exactly. The brain just circles the anxiety, simulating the problem repeatedly without ever executing an actual solution.
It is literally the neurological version of a blocked factory line. You're burning massive metabolic energy to produce absolutely zero progressive movement.
The structure is identical. The brain, the factory floor, the Go processor, they all default to repetitive, non-transformative cycling when the bottleneck is unresolved.
So how do we break it?
Well, to break this cycle, Toyota introduced two major architectural pillars, just-in-time and Jidoka.
Okay, just-in-time, or GIT. This is usually taught in business schools as just a method to, reduce warehousing costs.
Right. Keep inventory low to save money.
But structurally, the text defines JIT as a theology of trust and flow.
Which is such a profound shift in perspective. If we connect this to the bigger picture, it is the systemic refusal to create false abundance through hoarding.
So the objective is immediacy without defensive accumulation.
Right. A system drops its defensive posture because it genuinely trusts that production will arise in the correct proportion to demand.
Trusting the flow instead of fighting it. And then there's the second pillar, Jidoka.
Yes.
Jidoka is the principle of stopping the entire production line the exact moment reality breaks. If a single defect is detected, truth is allowed to instantly interrupt motion.
And this is deeply, deeply counterintuitive to a compressed system.
Oh, totally. Because if you are operating under intense external entropy, your immediate impulse is to hide the defect and just keep the line moving, right?
You just want to maintain the illusion of progress at all costs.
Yeah, pretend everything is fine.
But Jidoka recognizes that allowing a defect to move downstream is quite literally the localized manufacturing of future hell.
Refusing truthful interruption just guarantees exponential rework down the line.
Exactly. Jidoka corrects the fundamental architecture at the source long before the error can replicate and spread.
So what does this all mean? I mean, we have covered a lot. We've mapped a thermodynamic equation from high school chemistry. We translated it into bare metal memory architecture, and then we overlaid it onto lean manufacturing and human neurology.
It's a massive synthesis. And what it means is that we are observing a universal systems law.
A universal law.
Yes. Whether we are analyzing a human soul, a global supply chain, a Go routine, or a centralized institution, the physics remain absolutely consistent.
Heaven is a structural architecture that permits rightful, unobstructed motion.
And hell is an architecture that forces life to expend its vital energy overcoming the system itself before it can perform its actual work.
It forces you to fight the system just to do your job. And, to everyone listening, you can apply this lens to your own life immediately through value stream mapping.
It's a very practical tool.
Yeah, look at the architecture of your morning routine, your team dynamics at work, or even just your own cognitive habits. Identify that structural drag.
Ask yourself, where is the frozen potential?
Exactly. Where are you engaging in the double push of rework? Locate the bottleneck that your energy is just silently orbiting around every single day.
Because once you map the actual topology of the resistance, you can re-architect the boundary. You don't have to just keep burning yourself out, pushing harder against a locked door.
The next time you find yourself utterly exhausted at the end of the day, sit down and ask yourself a very specific question.
This is the real test.
Did you spend your energy actually doing the work? Or did you spend all your energy just fighting the friction of the system built around the work? Because the answer to that question will tell you exactly what temperature your local hell is running at.